Let's look at a similar example. Let's ask the question, what are all the solutions to tangent of x minus 1 equals 0? Before we get started, we need to remember, first of all, that we can use the unit circle to our advantage. Likewise, since we're using the unit circle, we should change all trigonometric functions in terms of sines and cosines. So for example, tangent is sine over cosine, secant is 1 over cosine. We want to use all these things to write it in terms of cosine and sine because the unit circle only gives us information about cosine and sine. So cosine of an angle is equal to the x-coordinate, and sine of the angle is the y-coordinate. Lastly, we want to use the periodicity of the functions to solve just in a finite range, and then extend to all numbers. So just like before, we solved from 0 to 2 pi, and then we tacked on some more stuff, and this is the same process we want to do. So let's go to the board. So here we have tangent of x is minus 1 equals 0, and we'd like to figure out what are all the x values. So what we can first do is just treat this like it's the variable we're trying to solve for, and move everything else over. So if we add 1 to both sides, we get that tangent of x is equal to 1. So this is a little more useful because if we know all the tangent values of tangent, if we know which ones have 1, then we can just use that information. And particularly tangent has pi periodicity, so we just add any number of pi's to the solution. Unfortunately, not many people know about tangent values, so what we can do is just write it in terms of sine and cosine. So tangent is just sine of the angle divided by cosine of the angle is equal to 1. And now what we have to do is see when this is satisfied. So we can look at this to say that since this is something over something else and that has to be equal to 1, then these have to be the same values. Another way we can see this is that we multiply by cosine on both sides. And what we see is that sine of x is going to be equal to, we have a cosine over here which cancels this one, and we have a cosine over here. So 1 times cosine is just cosine. So this is the equation we're now trying to solve for. We're trying to find all x values such that sine of that value is equal to cosine of that value. So from this point, we can use the unit circle. So we're looking for where is cosine equal to sine, and we can just keep track of, first of all, the quadrants. So in this quadrant, both the x value and the y value are positive, so this is a spot where they could possibly be equal. Here, the cosine value is negative and the sine value is positive. So if we want sine and cosine to be the same, then they can't be opposite signs, so this is not valid. Likewise, this isn't valid because the y-coordinate is going to be negative and the x-coordinate is going to be positive. And here, we have both terms will be negative. So these are the only possible zones that we can have cosine equal to sine, or cosine of an angle equal to sine of the other angle, or of the same angle. So now we're just looking at magnitudes. So if we just look across our unit circle, cosine has to be equal to sine. Well, cosine is equal to the x-coordinate, and y is equal to the, or sine is equal to the y-coordinate. So if we want these equal, we need equal sine and equal x and y. So we can go just through a diagonal line right through the x-axis, and we see that this is one solution. And if we look at the actual values, we see that cosine is equal to the square root of 2 over 2, and sine of pi over 4 is equal to square root of 2 over 2. Likewise, if we follow this downward, we see that cosine is equal to negative square root of 2 over 2, and sine is equal to negative square root of 2 over 2. So these are our only possible solutions. Great. So let's just write them down. They were pi over 4 and 5 pi over 4. So now in 0 to 2 pi, we have pi over 4 and 5 pi over 4 are the solutions. And just like before, we need to take the periodicity into account. So since sine is 2 pi periodic and cosine is 2 pi periodic, they both have the same periods. So we can add any number of 2 pi's to either of these, whether it's positive or negative, as long as they're integers. So therefore our solutions, and I should say all solutions, are x equals pi over 4 plus 2 pi, but as many as we want, so we multiply it by some variable n, or x equals 5 pi over 4 plus 2 pi n, where n is an integer.